to appreciate, and why do the forces have such different properties? Why are the strong and weak forces confined to operate on microscopic scales while gravity and the electromagnetic force have an unlimited range of influence? And why is there such an enormous spread in the intrinsic strength of these forces? To appreciate this last question, imagine holding an electron in your left hand and another electron in your right hand, and bringing these two identical electrically charged particles close together. Their mutual gravitational attraction will favor their getting closer, while their electromagnetic repulsion will try to drive them apart. Which is stronger? There is no contest. We already know. By the way, do you know which is stronger? Have you been paying attention? We already know who's going to win. The electromagnetic repulsion is about a billion. So 10 to the 42 times stronger. If your right bicep represents the strength of the gravitational force, then your left bicep would have to extend beyond the edge of the known universe to represent the strength of the electromagnetic force. Wow. Quite a workout there. The only reason the electromagnetic force does not completely overwhelm gravity in the world around us is that most things are composed of an equal amount of positive and negative electric charges whose forces cancel each other out. On the other hand, since gravity is always attractive, there are no analogous cancellations. More stuff means greater gravitational force. But fundamentally speaking, gravity is an extremely feeble force. This fact accounts for the difficulty in experimentally confirming the existence of the graviton. Searching for the smallest bundle of the feeblest force is quite a challenge. Searching for the smallest bundle of the feeblest force is quite a challenge. So we still don't have a graviton discovered yet. Isn't that crazy though, the 10 to the 42 times stronger thing? Experiments also have shown that the strong force is about 100 times as strong as the electromagnetic force, and about 100,000 times as strong as the weak force. But where is the rationale for our universe having these features? That is wild. Yeah, very wild indeed. This is not a question born of idle philosophizing about why certain details happen to be one way instead of another. The universe would be a vastly different place if the properties of the matter and force particles were even moderately changed. For example, the existence of the stable nuclei forming the 100 or so elements of the periodic table hinges delicately on the ratio between the strengths of the strong and electromagnetic forces. So, you know, if the electromagnetic force was more and there was more repulsion, that could have been an issue. If the strong force was more or less, that could have been an issue, forming the nuclei of all these elements that we have in the ordinary matter, right? So all of this stuff actually affects our everyday life very, very much. So we'll see what this section holds here. So, for example, the existence of the stable nuclei forming the 100 or so elements of the periodic table hinges delicately on the ratio between the strengths of the strong and electromagnetic forces. The protons crammed together in atomic nuclei all repel one another electromagnetically. So guess what? The protons in all these nuclei, and of course, the heavier the electron, or sorry, the heavier the element, the more protons you're going to have in that nucleus, right? Of course, the heavier elements also have neutrons, but you know, basically protons have a charge. It is, they're all positively charged. So this positive charge will repel each other electromagnetically. But thank goodness for the strong force, otherwise that would have been an issue. So how come we have the very strong repulsion between protons in a nucleus, but somehow they still are in the nucleus together forever happily, right? In stable nuclei of stable elements in the periodic table. Entire